This conference will now be recorded.
Hello, everybody. Jordan Girth here from the National Weather Service Office of Observations. Thank you for joining us for the Satellite Book Club Seminar Series. This is session number 115. The presentation today is titled Results from the 2022 Hazardous Weather Testbed Satellite Proving Ground Experiment. We're glad to have Kevin Thiel from the NESDIS Storm Prediction Center, a satellite liaison with University of Oklahoma, CIWRO. Our facilitator is Brian Mata, meteorologist from the National Weather Service Forecast Decision Training Division. Just a few reminders before we get started that this session, as you just heard, is being recorded. There will be an opportunity for Q&A after the presentation, and we're particularly looking for questions and comments from our forecast offices and regional headquarter participants. We ask that if you have not signed in with your name, for example, could be signed in with an office account. If you decide to ask a question or have a comment, please note your name in the chat box so we can follow up with you if necessary. We're always looking for future presenters for the Satellite Book Club. Please contact the TowerS team if you're available, or perhaps you have a previous presentation that's related to satellite imagery or products. We would love to have you as part of the seminar series. And if you're looking for training materials that you may be unaware of or may be unavailable, Brian Mata, who's here with us as our facilitator today, can help with questions regarding that. I'd like to thank our TowerS team, particularly Kashad Bowman, who works behind the scenes tirelessly to produce this great seminar every week, the Office of the Chief Learning Officer, the GOES-R JPSS programs for their support. Without further ado, let me introduce Kevin a little more in depth, who I already mentioned is the NESDIS Storm Prediction Center Satellite Liaison, having joined the University of Oklahoma's Cooperative Institute for Severe and High Impact Weather Research and Operations, CIWRO, in May of 2021. His master's and ongoing PhD research with the OU School of Meteorology involve operational and research applications of the GOES-R GLM, which opened the door to other satellite-based platforms like the Advanced Baseline Imager. Kevin hopes to further integrate GOES-R and JPSS products into SPC operations and enhance activities in the hazardous weather testbed to further benefit weather service forecasters. Kevin, we're glad to have you back at the Satellite Book Club today.
Thank you, Jordan. Yeah, so today I'll be talking to you all about results from our most recent Satellite Proving Ground experiment and giving kind of this high-level overview of that today. Advance to slides. There we go. Okay. So yeah, the reason why I wanted to give this talk today, I just wanted to go over the HWT final report, which is available now. We actually finalized that and have that now available online as of Tuesday this week. So it's really well timed to have this presentation here. But this has everything in it. But each section is broken down with a few pages, and we have full descriptions of the products and then applications from the forecasters and recommendations and even quotes too. So while it can look, reports are usually pretty boring, this has a lot of images, a lot of quotes. It's one that is a pretty nice read. But today's talk is going to be a shortened version of that report, hitting on some key pieces throughout. So for those who aren't aware of the Hazardous Weather Testbed or the Satellite Proving Ground and kind of what we do within the Weather Service, the overarching goal of NOAA's HWT here in Norman, Oklahoma is to be able to test and evaluate these new and emerging technologies for the Weather Service and make sure that these things can be implemented effectively into operations. So with the Satellite Proving Ground, we function in this role or under this umbrella of the HWT by looking in particular at satellite-related products and how they then can be implemented into the Weather Service as well. This year, we had a 3-week experiment that was entirely virtual. We had 6 product suites, and I'll explain those a little bit later. We had 19 total forecasters. So in the past, we had you would see developers and forecasters and other researchers all within the HWT space here within the National Weather Center, and also people working in operations behind certain desks on AWIPS. This year, and we also did this last year as well, we had group discussions in Google Meet and then had individual Google Meets as well for the individual weather forecast groups within our simulated WFOs. And so we had to move to this online format as of 2020, and we built upon that some this year and helped improve that experience. So with how our forecast is, or how our experiment is set up, we collect data in a number of different ways to be able to just really understand how forecasters use these products and why forecasters use certain products when and how they influence things such as issuing warnings and also DSS guidance. So we have things like blog posts, which are more equivalent to forecast journals. We've got surveys, daily discussions, and then we added some new things this year as well. We added a warning in DSS form. So anytime a forecaster issued a warning or also DSS messaging, forecasters were able to go into this form, fill this out, say what they had issued, and then also explain briefly why they issued what they did. So it only took them about 1 to 2 minutes to fill out, but the information there was actually really interesting to see this year. We also had public graphics, which was a more experimental thing that we were trying out this year. And this was to understand if you had to communicate this information to the general public, how one might do that, or even to an emergency manager or any kind of DSS partner. And so we'll see a few of those later too. But we did increase our emphasis this year quite a bit on decision support services, and had about 1 to 2 events of those every single day that were simulated, or they were mock DSS events that forecasters then could work with. And this worked, and this had some really interesting results that I'll also explain later. But yeah, so we do our operations on live weather. So we don't have any pre-canned events. So everything is as it happens. We don't know what's going to happen, and the forecasters don't know what's going to happen. It presents a lot of really interesting cases. We run everything also through AWIPS in the cloud here, supported from the National Severe Storms Lab, and have these instances set up that forecasters are able to access and then use most of the products in AWIPS. So here are the products. We had 6 total. And so we have some new ones and also some returning ones here as well. And so I'm going to briefly kind of go over those products and kind of give a quick rundown of what we were testing this year with each product suite. So with the geostationary lightning mapper, or the GLM, the gridded products, we're back in the test bed with a few different alterations to data visualization for flash extent density, which is the currently operational GLM product. Additionally, the minimum flash area and total optical energy products were evaluated to assess their utility. Also in operations, whether by themselves or when paired with other GLM or ground-based lightning products as well. From NewCaps, there were 3 core product suites that were evaluated. The NewCaps profiles, which were, of course, the profiles that are currently operational in AWIPS, with additional input from the MEDOP satellites along with Aqua. We also had gridded NewCaps data that was available in that planar format, and then also modified NewCaps, which uses RTMA data to modify the boundary layer of the NewCaps profiles to help improve their measurements at the low levels, as that's where sounders in LEO typically tend to struggle. With the next product is optical flow winds. This uses the AVI mesoscale scenes to produce high resolution, spatially and temporally, wind data at cloud top of various cloud features. Resolutions of about 2 kilometers and output about every 3 minutes or so. These data had one new addition this year, which was a divergence product that forecasters had asked for last year and we wanted to evaluate again. The next one you'll see there, it's a kind of a wonky acronym, but PHS, NNW, NAVI. Oftentimes this was just called PHS, and you might hear me call that later. But the PHS product is actually a model. The PHS model is a mesoscale model that is able to take in information from those sounders in low Earth orbit, along with integrating AVI information, and that is then fed into this mesoscale model with output on the roughly the same resolution of the HER. They're available in AWIPS, and this data was available hourly, out to about 7 to 8 hours for those forecasters, and available across the central and eastern United States. We also had ProbSevere version 3. This version is an improvement over version 2, which is the currently operational version with a brand new machine learning model that's been applied to the data. It takes in more data for these probabilistic outputs and looks to improve its calibration along with its overall performance. There's also the new time series tool that the developers wanted to continue to evaluate within the test bed. And then lastly, we had ProbSevere Lightning Cast. This is another machine learning model different from ProbSevere version 3, but ProbSevere Lightning Cast provides probabilistic output of the potential for an area to observe a GLM flash over the next hour. And this is only based upon using 4 bands of the ABI at one period in time. And this can be done across the mesoscale scenes, the CONUS scenes, and also available both day and night. And also just to make sure I mentioned as well, with ProbSevere version 3, this provides output for not just general severe, but also for the individual hazards. So that's tornadoes, hail, and wind also over the next hour. So really providing this probabilistic output from those 2 ProbSevere products, but with different applied inputs and machine learning methods that are applied there. So kind of getting back into what the proving ground is and what we were able to, or how an average day is usually set up here. Most days began with a daily debrief, talking about what we saw from yesterday and kind of this group discussion. We then had, after a brief forecast discussion of about 10 minutes or so, we then would select which county warning areas we wanted to target each day based upon where we thought there would be the greatest potential for evaluating the products, and also peak severity and peak impacts in weather. We then got set up in AWIPS, and forecasters were more kind of doing mesoanalysis and monitoring things in a pre-CI environment most of the time. Of course, this was highly variable. Of course, there were some days where we had to hop right in and storms were already going. But once you had either CI or storms entering your county warning area, it was then be monitoring those storms, issuing warnings in DSS, and then also writing up more blog posts and making graphics, and then ending the day with the daily survey. So we pack a good bit into this 5 hours every day, and we then run this across 4 days each week. So we had a good number of hours of operations time that we were able to get in this year. But what I want to do to show kind of the results of this project is going through what the average day might look like and kind of going through this timeline and showing how the products got used in different scenarios throughout each day. So we're going to hop right in and start looking at some mesoanalysis as we're coming right in and getting things set up for the day. So as forecasters are pulling up their data sets, they're going to look at a few different products here, NewCaps and mesoanalysis. I'll talk about NewCaps here for a little bit. But with NewCaps, a lot of that was doing some inner comparisons of those data that were currently available with the SBC mesoanalysis, along with the PHS model, and even and also soundings from earlier as well, looking for changes in the mesoscale environment, and also using cooperating information to build confidence in the environment, in the storm mode, in the convective features, and even CI areas as well, areas to watch there. Now this year, one of the things that NewCaps really wanted to hit on was the utility of multiple overpasses and how those can be leveraged to higher frequency data inputs from NewCaps into operations. And this was especially useful used with Aqua and then also NOAA 20. Both overpasses came roughly around 1:30 local time, depending on where you were, and they came about 1 hour apart. And so that time difference then allowed for forecasters to have that chance to just look over that data and look for those changes in a much shorter time frame than on the order of every 12 hours or so, like what you might have with your typical RAOB. So this forecaster, there's a quote from a forecaster in a blog post here in the bottom left that you can see, and it talks about how they had actually 3 passes right before convection initiated, and they helped increase their confidence of what areas that they could see where they could see more intense convection, and that they noticed a bullseye about 3,000 Cape there in East Central Minnesota that they wanted to then watch further. And you can see that also in the mesoanalysis data. So they were comparing those 2 data sets and able to then leverage those overall. In terms of additional feedback here, in terms when using this data for mesoanalysis, looking at data quality was of course very important for the forecasters to help build their confidence. So along with those inner comparisons, being able to understand the limitations of the new CAPS data, how you might see smoothing in the mid or lower levels, and how to interpret that data effectively. Also within gridded new CAPS, there was some discussion of if retrievals that didn't pass the new CAPS overall or their quality control algorithm, if they should be put into the gridded new CAPS. As last year, forecasters stated that they wanted that data even if it wasn't valid because they didn't like the gaps in the data. However, this year, forecasters also expressed that they didn't like having erroneous data also mixed in the gridded new CAPS retrievals as well. So there's some back and forth that's kind of been going on between the test beds. Also, the quantity and timeliness of data, and these two are kind of intertwined in a way. Forecasters consistently stated that they just generally wanted more data, and also that there were a number of times when the data didn't, the overpass didn't come in at the right time, and so having that sounder information come in more reliably and at greater or at faster intervals was then important also for the forecasters. Now with the PHS model, they had quite similar applications here as well. Oftentimes also comparing with the SBC mesoanalysis to see how those changes or to also build confidence in the environment. Just doing inner comparisons between now what is two different models actually. And identifying areas of possible CI was one of the things that was picked up by the developers that they really were stressing in training beforehand, especially when you have gradients in CAPE and in other convective parameters. And so we can look at how PHS was used. And most of the time, as you can see here in the upper right-hand corner, there's this bar plot here. You've got that forecasters typically used these data between the period of about 0 to 4 hours. And it really was helpful for situational awareness before and then also during an event as you forecasted out in greater hours, looking at the evolution of the environment ahead of storms and even the recovery afterwards. Maybe you have earlier convection in the day. So there's a quote from a forecaster down here in another blog post talking about how overlaying the visible data with the PHS gave them this kind of visualization where storms are initiating along the sea breeze and also along an approaching and decaying MCS as well. And so being able to understand where convection would initiate over the next few hours early on in the day to inform their future decisions. There were some display recommendations. The first one was just having more products available in AWIPS this year. The PHS group added a handful of products in, and forecasters said they wanted to have more fields in to do more direct intercomparisons. All of the data sets were available, or many more variables were available online through a web display. And forecasters did comment that they wanted to see also improvements made on that as well, as that at times was difficult to read and interpret, especially when looking at more smaller scale details. So now that we've kind of assessed our mesoscale environment, now let's start looking for where convection might be initiating. And so one of the things we can turn to readily for that and was often turned to was prob-severe lightning cast. And so as you would see probabilities increasing in certain areas, that then gave forecasters a clue of where they might be able to see initiating storms early on and what areas that they should be giving more attention to. In general, when forecasters were asked what their actionable lead times were for CI from lightning cast, a majority felt that this fell between about 10 to 30 minutes or so, as you can see there in the upper left-hand corner in that plot. And so so there is an appreciable lead time that we can have for CI in those areas. It also is a good situational awareness tool. And there was a few cases of that, and one I wanted to point out is a blog post from June 9th, where this forecaster talks about how initially they thought that storms were going to form first in the southern portion of the CWA. However, they then noticed the lightning cast probabilities popped up in a different area than what they expected, and they then had to shift their focus further north. So it helped them recalibrate even before storms had actually initiated, and they were able to then give attention to the areas that needed it most at that given time. One other feature pointed out from lightning cast was the performance in overcast areas. And so when you had areas of dense cirrus, as this other blog post from June 6th points out, that those can mask the signal of weaker convection, that it's harder than for those for the other AVI bands to pick up on that within the machine learning model that lightning cast uses. And so one idea that forecasters had was to integrate that radar data into the model to be able to improve the performance in those kind of situations. Also, we never asked about this at all, but it came up consistently in the weekly surveys that forecasters thought that lightning cast would be very useful for TAP amendments. So while we didn't do anything related really to aviation throughout our test bed, that forecasters thought this would already be useful without having actually applied it anywhere directly. And so that's something that might be a future avenue for either us or for anybody else that is interested in evaluating in that way. That potentially also for aviation applications is another great area to follow there. So once you have storms that have initiated, maybe you're working a DSS event and you now want to understand, okay, well, where are storms moving to? How can I then prepare my DSS partners and those that I need to communicate to throughout these events? And so what we noticed here right away is that there was greater emphasis on lightning data, on being able to use those, and along with radar and a few other products. But lightning data had an increased priority in these events. And this shows up quite well if you look at the product contributions from all of our DSS messages. So when asking forecasters how the different products contributed to their messaging, out of the 52 messages that were sent, 41 mentioned prob severe lightning cast explicitly, and 35 mentioned the GLM. We also then see prob severe version 3 with 13 and PHS with 6. And so, but we see a greater emphasis on the lightning products that were put into the test bed. This involved the advection of storms towards DSS events. And so forecasters, when they were asked about actionable lead time for thunderstorm advection, you also see roughly that 10 to 30 minute range of actionable lead time. But you also see an increase there in the bottom left-hand, on the far right-hand side of that figure, though, of greater than 40 minutes as well. And so being able to, depending on what your event is, that the probabilities may be able to be tailored in a way to help you assess that risk and the advection of those storms as they're moving towards, and you have the probability contours then cross over into those areas. You can see an example of this kind of thinking here with a 45-minute heads up on a DSS message from a mock kids triathlon that was being held, I believe roughly right around Birmingham. And so that this forecaster gave this 45-minute heads up, and it actually ended up, they ended up having a lightning over that site about 48 minutes after this message was sent out. So this is a really interesting application to see. The forecasters also leveraged the AWIP's time of arrival tool as well when paired with the lightning cast probabilities. And then we also had the view of flash area from the GLM was also leveraged. And I'll show that in other examples, but one thing that had to be considered often was parallax. And so as you have that shift in where you're observing features from cloud top from satellite versus maybe your ground-based lightning networks or radar, how you then make that shift. And so hopping from different areas from day to day, that shift was always changing, and that sometimes presented difficulty for forecasters to really put these in context spatially. And so being careful about the parallax correction each day was also quite important. Now with the DSS events, also forecasters sent out messages through these graphics. Over half of them used the prob severe lightning cast data sets and then overlaid the GLM data on top of that and leveraged that for their messaging. And so this forecaster is talking about the events that are moving, or the storms that are moving towards their DSS event that you can see there in the yellow ring on the right-hand side of that graphic, and then also how your perceived threats were for these events, and also actions that those should take during the event as well, and providing that kind of guidance. Another one here, just featuring just the GLM data, shows lightning flashes that are moving out ahead of the storms, as the second bullet point points out, for what was a Youth World Series of DSS event that we were covering. that day. You also see the lightning or the prob severe product as well. Those thunderstorm contours are put there as well, just as a spatial reference too. And so being able to use these products as a communication device was really interesting to see. We hadn't tested this before in the test bed, and it was just, yeah, a really interesting thing to find. So when it came to now, as maybe things are ramping up, you now are looking at monitoring more closely, deciding if you want to issue warnings, where to issue warnings, for how long, those kind of things. Very often when deciding whether or not to warn on storms, as we saw last year, the big thing was trends. Trends were really important for the forecasters to be able to pick out with these products. And so, as you can see in the bottom right-hand corner, there's a quote from a forecaster from a blog post on June 16th, talking about they saw upward trends from prob severe, and then also increasing severity from the GLM as well. And that was a big confidence booster for them to put out a warning. There were other cases too, where maybe prob severe was holding steady and the GLM didn't look great, but the storm on radar maybe looked intimidating, and the forecaster decided, well, I'm not seeing these all aren't lining up, and so let's hold back on the warning a little longer, and then also reducing those false alarm rates as well. But with the GLM data, those trends that forecasters often looked for were increasing flash extent density paired with decreasing minimum flash area, which is indicative of strengthening updrafts and increasing thunderstorm severity potential. Prob severe version 3, increasing probabilities, often from the individual hazards and also the overall from the overall prob severe product, but really looking at those data from the time series tool. And forecasters again found very useful. It was a very strong support of that tool, which was very similar to what we also saw last year. And you could, this forecaster here in the bottom left also points out the improved calibration of prob wind in this scenario, but that prob wind, when looking at that data in the time series tool there, as you can see with the red arrow on the bottom, that it drew attention to a scenario that might have actually been missed if they hadn't noticed it, as things didn't, or that the storm didn't look very menacing via radar based upon where they were. And so that the prob wind tool was able to pick up on additional variables that the forecaster didn't have up and was able to draw their attention to that storm, and so then they could issue a warning in a more timely manner. Additionally, forecasters did also, in a number of cases, look at the optical flow winds product and looked for increasing divergence from the optical flow winds at cloud top. These data could be a bit noisy in the current display, and forecasters recommended being able to make display improvements of those to increase its overall utility throughout the test bed and for hazardous weather. But kind of boiling things down and helping to kind of wrap things up a bit, I know we're kind of hopping from section to section here, but I really wanted to hit on some major takeaways that we had from the 2022 experiment. We'll go through those kind of product by product here. But from the GLM, while we have flash extent density as a useful product, we already know that it's currently, or it's in operations, but that also the minimum flash area product is also quite useful, especially when paired with flash extent density. But it's even useful on its own too in a number of scenarios. With new caps, as we talked about earlier, that having more timely sounder information for those forecasters may increase the utility of that data from mesoanalysis. Being able to have that data when forecasters need it and in a convenient manner was really important for them. It was something that was consistently pointed out throughout the week. With optical flow winds, display improvements were really needed in that product to help fully leverage that, especially in the divergence fields. And so to have this product back in the test bed, more R&D is going to need to be done. A different direction might need to be needed there. But yeah, especially with the divergence fields, having an update there or having those products updated in some ways for future test beds. For the PHS product, we found the model is most useful for those short-term mesoanalysis on the order of 0 to 4 hours. And additional testing would be needed, or is definitely encouraged, with more products available in AOEBS 2. So, and also creating some direct intercomparisons with SBC mesoanalysis data and other data sets, or other model data sets. With prob severe lightning cast, forecasters found that this could be a vital resource for DSS events, and also for situational awareness and identifying CI. And in some ways, those all can then be interconnected. And those DSS events especially being able to communicate those to partners, forecasters felt the most confident out of all the products, communicating those outputs and those probability contours to forecaster or to to DSS partners, along with being able to just maintain awareness in cases of CI, especially if you are in these rapidly evolving mesoscale environments. Prop Survey version 3, similar to last year, the time series tool was a great addition and was quite useful for monitoring those storms and also warning decisions. And this was further improved by the improved calibration of the prob wind and prob hail outputs from version 3 there as well. So there are many more takeaways that we have, and those are all in the final report. This has just kind of pared it down into a kind of a hard sentence that's just the leading one from each product, but there's a lot more that we go into there in the final report, and so this is that kind of high-level overview. So just kind of wrapping up for today, I of course want to thank the GOES-R and JPSS programs for continuing to support this work. We're working to accelerate the products, these products into operations and to help drive that kind of research to operations and operations to research paradigm. And without their support, this is something this definitely wouldn't be able to happen. But it also takes a lot of people to put together this whole entire test bed. Roughly about 30 people in total worked on this test bed to help kind of make this all happen. So that's talking about everything from the forecasters, all of our developer teams. We also had a number of visiting scientists and other observers in the test bed too. And then I also want to give by shout out our CIWRO AWIPS developers who did a fantastic job working with them every single day in the test bed to keep so that our cloud AWIPS could be fully utilized by the forecasters. And forecasters really felt they were able to use that in an effective manner to really mimic operations, which was the overarching goal that we had. So wrapping up here as a reminder, the final report is available online. I'm going to post a link into the chat that'll have that data and have that report for you as well. And then I'm also going to post a link to a link tree. And that has a list of blog posts. And then also, if you want to look at what these data actually look like, I've got links to the product web displays available there as well. So I'm going to put that into the chat. And that way you can all have that. But I want to thank you all for attending today. And I think Brian has to give some questions, or has to give an announcement. And then after that, I'd be happy to take questions about the test bed and about any of the products. I can answer those to the best of my ability there. So thank you.
All right, thanks, Kevin. While the questions are queuing up, we'll make a brief announcement here. There's going to be a survey link in the chat for people to provide feedback. And a week from today, Joseph Patton, Assistant Research Scientist with CIWRO, will summarize the GLM Science Team meeting. So without further ado, if you do have any questions about configuring your AWIPS or access to data sets, please reach out to John Evans or Lee Byerly or Kashad, and you can even hit them up in the TowerS chat room in NWS chat. So let's get into the questions. I believe Javier got his question in first. Who is processing Aqua and MEDOP new caps for AWIPS? And did the forecasters have anything to say about new caps fields and soundings versus model fields and soundings, i.e. pros and cons?
Okay, I see that question, yeah. So that's a really great question, Javier. So the processing for Aqua and MEDOP, I can't remember right now who that is, but all of the new caps data, I believe, is processed through, I want to say it's processed through SIMS and then sent via the SBN. And so So yeah, that direct broadcast, and then using the SP or the SBN is how we then were able to get that data fed into AWIPS. And so we talk about that a little bit in the report as well, and how that data is fed in, kind of in the introduction part. NewCaps is by far our biggest product, that's our biggest product suite that's put in. So there's a lot to unpack there. And so, but yeah, getting to the second half of your question there about the NewCaps fields and soundings versus the model fields. Oftentimes, there was a figure I almost put into this presentation, but for time I didn't. But it involved the most used parameters from NewCaps and mostly looking at also gridded NewCaps on those fields. And most often, forecasters were using kind of what I would call like the bread and butter variables. So things like SIN and CAPE, and also looking at LCL heights, and just those fundamental aspects is what forecasters often looked at. They also looked at mid-level lapse rates as well, and even just lapse rates in general, and comparing those with model output, and especially with the SBC mesoanalysis were the big things there. So the resolution was one thing that forecasters did talk about, but being able to have the aerial perspective as opposed these, and having an aerial view of observations was useful for them. So being able to look at how things were changing over a larger area as opposed to a point sounding, which just gives you one point in data at one point in time. And so there was some advantages there, but then when you had cloudy scenes, you also then had or more retrievals that were either marginally passing or not passing the NewCaps quality control algorithm there. And so then that also impacted the utility of the data too. Or you just had the timeliness of the overpasses. And that was I think one of the biggest limitations of the data right now, was just the timeliness of the data coming in at the right times that forecasters could leverage them. So it's great when you have the overpasses and you can get all this data in and work with that. But sometimes maybe you were 50 miles too far west of an overpass and you just didn't get the data in, and you're kind of at times could be left a little high and dry there. So yeah, to kind of sum up, that was kind of a long-winded answer, but to sum that up, that having that aerial view was really nice for the forecasters, and being able to compare that directly with the model fields was a good tool. But also making sure that timeliness of that data comes in was kind of the biggest con of the data, and being able to provide those comparisons there.
All right, thanks, Kevin. Next question and comment is from Michael Pavlonis. Kevin, great job running the experiment. The report is an excellent resource. How will you ensure that the report reaches product and service portfolio decision makers in NWS, NESDIS, and OAR? Not all will be aware it's available and contains actionable recommendations.
Yeah, that's a great question, and that's something that is kind of the second half of the test bed. After all the dust settles and after the report's written, there's another kind of section here that I kind of look at it as almost going on a promotional tour of being able to disseminate this information, and it's done a lot through presentations like this. So presenting at the Satellite Book Club, I presented for the NWS Lightning Working Group. I presented also for the satellite training team, presenting at AMS, also at the GLM science meetings, presenting and being able to then serve as that kind of constant focal point and resource is really kind of the tactic that we've taken so far with the data. But if there are other ways that we can disseminate this information more widely, I'd be more than happy to hear that, because yeah, we do try to put in actionable recommendations and things that the developers and then also forecasters and training staff can also do to help enhance the integration of these products operationally.
All right, very good. Next comments from Scott Wenstrom. Says, agree totally about Johnny and Justin. The cloud AWIPS worked so well for this in conjunction with the Google Meet sessions.
Yeah, Justin and Johnny were I can't give them enough credit for what they've been able to do the last few years with cloud AWIPS and really making that process quite seamless for the forecasters to be able to log on and working with data in a matter of 10 minutes. Oftentimes, we set the radars and they then fire up the instances as we're picking out our forecast areas. They set the localizations, and then we just go. And this year, especially, I mean, it was very smooth, and so yeah, it's been a really nice adaptation, and it really has changed how we kind of view the test bed and what we're able to do.
All right. Victoria put a little more detail on the NEWCAPS data flow question. So Javier, you can copy that if you wish. Ken Pryor has the next one. Kevin, great presentation and thanks for showcasing NEWCAPS. As the NEWCAPS SME, I'm glad to see the favorable results from the HWT. And then Ken, did you have a question?
Yeah, I think it's down below. One more.
Oh yeah, okay.
Yes, this is Ken. I do. I have another question and a comment further down in the chat.
Okay, was any boundary layer adjustment used for NEWCAPS and mesoanalysis example?
Yeah, so there were examples that I wasn't able to include them for time today, but there's a section in the report dedicated just to the modified NEWCAPS, which has examples of modifying the boundary layer and how the forecasters responded to that. Overall, forecasters seem to like the improvement in those data when using the modified NEWCAPS method there that was employed, and so. Yeah, I would default back to the report for specific examples that we had there. But yeah, that was used, and forecasters generally did like that. It wasn't a perfect system, but it was one that forecasters did like overall.
Okay, was there an opportunity to use the evening MEDOP NEWCAPS retrievals?
With the evening MEDOP retrievals, those ended up being, I think, a bit too late for us. So based upon our timeline for the experiment, we ended right around 23Z. So if we were going too deep into the evening, anything past 0Z, also that time, you might maybe have the overpass closer to that period. I can't remember the exact rough time that you would see those evening MEDOP overpasses. But the big one that we focused on was that midday with NOAA 20 and Aqua, and then using the early morning MEDOP overpasses as kind of to set up the environment overall. So we weren't able to use the evening ones in the experiment.
All right. And Doug, did you have a question? Okay, we'll catch up with Doug probably after the webinar. Thanks, Kevin. We'll throw it back to Jordan now.
All right, thank you so much, Kevin. Thank you so much, Brian. And I really appreciate all of you taking the opportunity as our audience today for this presentation. As has already been said, a week from today, Joseph Patton with NESDIS-SPC will summarize the GLM science meeting. So if you're interested in that, which I hope you are, I hope you'll join us once again next week at our normal noon Eastern time. In the meantime, if you have questions about the configuration of satellite products, please get in touch with our Tower S team via email or via the NWS chat. Or if you have questions about the Satellite Book Club, Prashad Bowman's email address is right there on the screen. Until next week, hope everybody has a good equinox, good start to the fall season, and enjoys some of the cooler weather that's settling down over the Midwest and soon into the Northeast and Mid-Atlantic as well. Take care, everybody. Thanks again. Appreciate you being with us today.